All right. You guys hear me okay? Can't tell if this thing's working or not. I don't think it's working, but it's on. Okay. Well, we'll just have to work without it. All right, so you probably have noticed at this point that I've got my laptop out. I am recording class videos. As long as we are meeting in person, videos will be posted probably on Box, and then I'll link to them on Canvas. But if you are concerned about the coronavirus, if you think you are in a high-risk group, by all means, feel free to stay home, send questions by email, that sort of thing. But what I'm planning to teach isn't going to change. So I have posted or started a discussion board for Exam 2. If you've got questions about the material, whether you're attending class or watching the videos later, post questions here. Chances are, if you've got a question, somebody else probably has the same question. All right, so Kevin and I will monitor this and answer questions as they come up. And so that's basically my contingency plan at this point for this class, is going to be just to post the lectures. And if the university does move to canceling in-person classes, I'll just do the lectures at home and post the videos. All right, make sense? Who thinks this whole coronavirus thing is scary? Who thinks it's overblown? Okay, all right. So that's fair. There's some pretty scary stories coming out of Italy, but yeah, we'll see. I hope that you all are right. So, all right. So today we are going to start in on chapter 5. And every other chapter that we've done up to this point has been mostly us working with a single variable, right? So we did counts and proportions and estimating what does the population look like from our sample, for proportions for quantitative variables. We talked about confidence intervals. Now what we're going to talk about is how to see if we have evidence from a sample whether two groups differ in some way. And so just like we started with a single variable, we started with proportions, we're going to start comparing two variables by comparing two proportions. All right? So today is mostly kind of getting a feel for how this whole two variable thing works, looking at visual summaries and how to kind of explore a two variable problem. Thursday, we will look at simulation-based methods for two proportions. If you happen to have laying around like two different colors of index cards or a deck of cards, it might not be a bad idea to bring that on Thursday. We're going to be playing with simulation methods that involve shuffling cards around, so that'll be fun. And then the final section that we'll do next Tuesday is theory-based methods. So again, following more or less the same structure that we've had in every chapter thus far, but now with more variables, more things to get mixed up. So, all right. So when I was making the slides for this, I got kind of bored with the examples in the book and decided to use some data that I had laying around. Anybody familiar with Quentin Tarantino's films? Yeah. Okay. So somebody actually went through every one of his films and wrote down timestamps for every curse word. They wrote down what the curse word was, too. I just didn't include it in the table. Every curse word and every time somebody died. So I've got a data set of events in Quentin Tarantino movies. And I think at this point what we want to know is, does the frequency of curse words in this data set of events change from Kill Bill Volume 1 to Kill Bill Volume 2? having never seen these movies before, I can only imagine what they look like given the number of deaths and curse words in them, but this seemed much more entertaining than the lame example in the book. So, all right. So if you are curious, there is a link to the data in the slides if you want to see the uncensored version. But, all right. So given that we want to know about this death to curse word proportion, right, for each of these movies, what's the observational unit? So it's every instance, right? Every event, be that a death or a curse word in a movie. All right, so which columns do we need from this app? So from this table, what columns do we need to do this analysis? Yep, so we need movie, we need type. Time is an extra variable that we don't need. Right, that's just the timestamp. All right, and then when we summarize this data, if we've got movie and we've got type, each of those have two options, right? We don't need all like 200 and some odd rows in the table. What we really need is a count of how many unique times the movie and type combination shows up, right? So we can count up, there are this many curse words in Kill Bill 1, there are this many deaths in Kill Bill 1, there are this many curse words in Kill Bill 2, this many deaths in Kill Bill 2, right? So the name for that summary table is a contingency table or two-way table. And it's particularly useful when we have two categorical variables. Okay? So this is a lot shorter, easier to read, easier to use table. Strictly speaking, a contingency table would, just include the first three columns and first three rows, but usually we add totals on the end because that makes the calculations easier. So on exam 2, chances are I'll give you something to this that looks like this to work with for this type of problem. So that would be one hint that, hey, I'm dealing with a difference in two proportions type of thing because I've got this summary table. All right, make sense? Pretty straightforward? Trust me, this is much easier to work with than the giant list of everything. All right, so what we'd want to know is if Kill Bill 1 has a higher death curse word proportion than Kill Bill 2, but the groups are different sizes. So Kill Bill 2 looks like it was, kind of lame in terms of death to curse words. It's just a lot of cursing and nobody dies, right? But overall, there are fewer events, right? So it's not easy to directly compare the numbers. What we have to do is divide everything by the total. So 63 over 120, 57 over 120. That'll give us the relative proportions of deaths and curse words for Kill Bill 1. Then do the same thing for Kill Bill 2. And that gives us something that we can directly compare, right? All right, so can't work with counts, we have to work with the proportions. So far, so good. If we want to show this, one nice way to do that is to take those proportions and then if you draw a bar that just goes up to 1 and then segment that bar per group, right? You can get deaths and curse words, something like that, right? And that lets you very clearly see the relative difference in the proportions. Does that make sense? So, and again, as long as you get one of the two proportions from a row, you can make a graph like this just by hand pretty easily. It's pretty natural to think of reading this as Kill Bill Volume 1 has about the same number of deaths and curse words, right? And Kill Bill Volume 2 has a lot more curse words than deaths. The concept underlying that, though, is a little bit trickier. It's called conditional probability, or conditional proportions. And the way to think about it is, given that I'm looking at only Kill Bill Volume 1, right? What is the proportion of deaths to total events, right? Given that I am looking at Kill Bill Volume 2, right? So you're restricting the stuff that you're looking at, and then calculating a proportion. So there's some mathematical notation for that, but you don't really need that unless you're interested. So, but conditional probability and conditional proportions are pretty useful things. All right, if we want to summarize the difference in these two groups, right, two sets of two groups, one way we can do that is to compute something called the relative risk. If I'd been really on the ball, I would have gone and gotten coronavirus numbers for different age brackets or something. But relative risk is actually really common in public health and medicine. So you'll read things like, you are 5 times more likely to get cancer if you smoke than if you don't. That is a relative risk. Okay? The proportion of people who get cancer in the smoking group is 5 times lower, right? Or 5 times higher than the proportion who get cancer in the non-smoking group. Okay. To calculate the relative risk, you take the proportion from whatever row you're comparing, divide that by the next proportion from the next row, right, of interest. And you should get a number that can be anywhere between 0 and infinity, really. And we interpret this, so in this particular case, we've got, of observed events in the Kill Bill movies, we are almost 4 times more likely to see a death in Kill Bill 1 than in Kill Bill 2. Okay? So the relative risk is a nice single number summary of a contingency table. Sometimes it's more useful and easier to interpret than others. Right? All right, so in your groups, let's go ahead and do a practice table. This time we're working with Titanic data, and here the line that I forgot should say survived over top of no and yes. So these are the ones that died, these ones survived. All right, so let's examine whether the whole women and children first mantra actually applies to Titanic data. Okay. So go ahead and work in your groups. Take the next 5 minutes to talk through the variables and see if you can calculate the relative risk.
we're observing this. Very I think they were trying to see whether it be male or female, whether you have so gender would be the response. Gender would be the explanatory. Yeah, then the response would be whether the explanatory is gender. And then response is whether they I know. Is that saying yes, they died. Yes, they died. It's gotta be yes, they survived. No, it'd have to be yes, they died. Because the reason they died. Yeah, 126. So I think we have to take the no of whether we'd have to take the no. That they died. The no means it. Yeah, so the question is like, did they survive? It's either yes or they survived. I saw that. Okay. It's just true.
All right, everybody managed to get a relative risk? How many times more likely were men to die than women? Just ballpark it. Yeah, pretty close to 3, right? So men were about 3 times as likely to die as women. Somebody asked a question, how do we know which one goes on top? And basically the answer is read the question and kind of look at the order of the variables and the way the question is phrased. So in this case, for men versus women would, to me, say we're interested in that how many times more likely are men to die, right? So that would go on top. The other thing that I think I probably didn't really mention earlier that's important, when you're calculating relative risk, it's a good idea to figure out what you think the explanatory and response variables are. So in this case, the response is whether or not they survived, right? And we're explaining that by their recorded sex. Yeah? Make sense? So, yeah.
So for p hat, is it yes over total?
Say what?
For p hat, the numbers that you use, is it yes over total?
So we're looking at the relative risk of dying, right? So again, this is a very tricky thing you've got to read the question and then kind of set your math up accordingly. Because we're interested in the risk of dying, we're going to take female and divide by the total, right? So 126 over 470, that gets you the proportion of women on the ship that died, right? We're going to take the number of men that died, divide that by the total number of men, okay? And I've got these numbers written down over here, but so for men, the proportion is like 0.788. For women, the proportion is 0.2681. Then, now that we've got the two group proportions, we're going to look at men versus women. So men on top, women on bottom. So we divide 0.788 by 0.2681 and get 2.9393. All right? But yeah, these are kind of tricky, and you do have to read carefully when you're answering a question like that. All right? The translating math to, or translating words to math thing keeps coming up in statistics. All right, observational unit was each person, right? Two variables are sex and survival. And sex is the explanatory variable, and survival is the response variable. Okay. And if you're having trouble figuring out what the variables are, the explanatory variable is the one that you actually know the value of first, generally speaking. All right. So in this case, before the Titanic actually sank, we still knew every observational unit's sex, right? So that becomes the explanatory variable. In a designed experiment, your explanatory variable might be which group the participant was assigned to or which treatment they were given, but you still know that before you collect whatever response data you get, right? So thinking about values in time sometimes makes that easier for me. All right. So we're going to work through Exploration 5.1 in your groups. For the next little while at least. If you guys start finishing this up early, I can go on to 5.2 and we can maybe work in a little bit of test review the Tuesday before the exam. Or if you'd like to just be done as soon as you finish Exploration 5.1, that's fine, but I think probably it's worth deciding that now. So all in favor of being done with class after Exploration 5.1? Okay. All in favor of having a test review? All right. The test is next Thursday. It covers chapters 3, 4, and 5. So I was trying to get the test before you guys left for spring break so that you had spring break to not have to study. So unfortunately that means you have to study before spring break, but yeah. There is a practice exam already posted because we had some people that were out of town for various things, so. All right, so you can get the practice exam. Again, the format of the practice exam is pretty much the same type of thing as the format for the test. So, shouldn't be a lot of surprises. The key is already posted. I highly suggest that you wait to take the practice exam until you've gotten through most of Chapter 5 so that it's a good test for you. but that's up to you. You can also just look at the key and say, yeah, I know that, and then get a nasty surprise on the test. So, all right. If you guys want to work through Exploration 5.1, this is an example that I've seen quite a few times about a nurse who was working in the ICU, and people seem to die on her shift more than on other people's shifts. But it was a connection that only her coworkers picked up on, and it was just whether or not somebody died. In the ICU, people dying is not that odd of an occurrence, right? But her coworkers thought that she was killing her patients by giving them epinephrine. So this actually went all the way to trial. There was a statistical analysis of all of the shifts while this nurse was employed at the ICU, and they tabulated up shifts that she worked, people that died and survived, and then shifts that she didn't work with the number of people that, or the proportion of shifts where people died versus not, okay? So we've got two variables. We've got whether or not she was working and whether or not at least one person died. Right? They're both categorical. And we're looking at every shift, right? So that's the observational unit. Okay? It's a fun little puzzle, right? All right. So you're going to do all the questions for Exploration 5.1. The first 8 are submitted individually. That was, yeah. And the rest of them are submitted in your groups. The grader is going to grade a couple of the answers and then do the rest of it on completion. So, and he'll give you feedback on anything you answer, just like always. So, all right.